In today's lecture, let's review one sample proportion tests. Question 1, let's test the claim that the proportion of people who own cats is significantly different than 70% at the 0.02 significance level. Based on a sample of 700 people, we found that 69% own cats. Always the first step is to state the claim and the complement. In this case, we have the claim is those who own cats is significantly different than 70%. So we're claiming that the proportion is not equal to 0.70. The complement, or the opposite to this, is the proportion is equal to 0.70. Now we can state our null and alternative hypothesis. Our null hypothesis is going to be the one with the equal symbol. So we say P is equal to 0.70. For our alternative hypothesis, we're going to have that as the claim. P is not equal to 0.70. Notice that in the alternative hypothesis, we have a not equal symbol. This means that we have a two-tailed test. If we are too far below the proportion of 0.70, then we're going to reject the null hypothesis. If we're too above, we're going to reject it. This is a two-tailed test. Now for step 2, we'll state alpha. Alpha is given in the problem. It is 0.02. Now for step 3, we can use the formula. The formula is, we have z equals p hat minus p divided by the square root of p times 1 minus p divided by n. Now let's figure out what p hat is. P hat is in the problem, it's given. We have that of 700 people, 69% own cats. So what is x over n? Well, remember, x is the number of successes divided by our sample size. So we know in the denominator it's going to be 700. Now how do you find 69% of 700? Well, to do this, we take 700 and multiply by 0.69. This is going to tell me the number of successes. 700 times 0.69 is 483. So I know 69% of 700 is 483. That's our x, that's our number of successes. So that would be our p hat. And of course we can simplify this. This is equal to 0.69. Now we have everything that we need. We know p hat is 0.69 and we know p is 0.70, and that's from the problem. Our sample size is 700. So let's plug it into our formula. We have z equals p hat, which is 0.69 minus 0.70 divided by the square root of 0.70 times 1 minus 0.70, and we're going to divide that by our 700. Now let's enter this on our calculator. A good tip to remember is to use parentheses for the numerator, so the calculator can do the top and then divide by the bottom. This is our free Desmos calculator. Let's enter our parentheses first, then 0.69 minus 0.70, then we'll close off the parentheses, then we'll divide, and then we'll click the square root symbol here, divide by the square root of 0.70, another parentheses, 1 minus 0.70, then we'll close off this parentheses, and we'll divide it by 700. Our answer is negative 0.577. Z is equal to negative 0.58 when I round this, and so that's our test statistic. In step 4, I'm going to have to find the p-value, but remember this is a two-tailed test, which means I have to double the p-value. I want to find the probability of z being less than negative 0.58, but I have to double that at the end. So let's go to our z table and find the area to the left of negative 0.58. The area to the left of negative 0.58 is 0.2810. And that's from our z table. So we have 0.2810. But wait, we have to double it. So let's double this value. This is going to give us 0.562 for our p-value. This is our p-value, 0.562. Now in step 5, you can finally write our conclusion. I always ask, is the p-value less than alpha? And in this case, no, it's not less than alpha. We do not reject the null hypothesis. There is not enough evidence to conclude that the percentage of cat owners is not equal to 70%. Now, let's check our numbers with our statistics calculator. So let's go to our hypothesis test for a population proportion calculator, and let's check to make sure our answers are correct. I know the sample size is 700, and the number of successes was equal to 483. I know our null hypothesis was equal to 0.70. And we had a two-tailed test, so make sure you select not equals and calculate. Our test statistic is negative 0.577, which is exactly what we had. And our p-value is 0.5637, which is very, very close to what we had. We had 0.562. So our solution was very close to the computer. That means we did this problem correctly. Question 2. Only about 18% of all people can wiggle their ears. Is this percentage different for millionaires? Of 337 millionaires surveyed, 67 could wiggle their ears. What could be concluded at alpha equals 0.05 level of significance? What is our claim? The claim is 18% of people can wiggle their ears. So we're supposing that p equals 0.18, and the complement will be the opposite of this. That means p is not equal to 0.18. Now we can do step 1. For step 1, we'll state our null hypothesis and our alternative hypothesis. The null hypothesis is the one with the equals. So in this case, it's the claim. P equals 0.18. And the alternative is the complement. P is not equal to 0.18. Step 2, our most favorite step, is to just state alpha. Alpha equals 0.05. In step 1, notice that our alternative hypothesis uses the not equal symbol. Again, since it's not equals, we know this is a two-tailed test. It's two-tailed because we will reject it if it's too low or if it's too high. In step 3, let's use the formula z equals p hat minus p divided by the square root of p times the quantity 1 minus p divided by n. P hat is x divided by n, or the number of successes divided by n. Let's look at our problem to figure out what is our number of successes. We know that 67 out of 337 can wiggle their ears. So we have x is equal to 67, and we're going to divide it by 337. P hat is approximately 0.1988. Let's plug in the values. We know that p hat is 0.1988. P is equal to 0.18. Our sample size is 337. And that's all we need. Let's plug it in. Z equals p hat, which is 0.1988 minus p, that's 0.18, divided by the square root of p, which is 0.18, times 1 minus 0.18, divided by 337. Let's go to our calculator. I will enter a parentheses first for the numerator. Let's type in 0.1988 minus 0.18 and then close the parentheses off. Click divide. Then enter the square root of 0.18. Open another parentheses. 1 minus 0.18. Close that parentheses off. And then divide it by 337. We have our test statistic is equal to 0.898, or we could round this to 0.90. Z is approximately 0.90. Now in step 4 we can find our p-value, and that's going to be based on our alternative hypothesis. We have our z is equal to 0.90. So let's look at our alternative hypothesis. We know this is a two-tailed test, so we want to figure out this area for the z equals 0.90 in order to find our p-value. So we're looking for the area to the right. Since z is a positive number, we're looking for the area to the right, and since this is a two-tailed test, we have to double the p-value. We have to remember to double the p-value because this is a two-tailed test. We're going to take our probability and double it. But remember, we're looking for the area on the right, and our z-table is always the area on the left. So we'll have to subtract from 1. We'll do 1 minus whatever we get for the area to the left. Let's go to our z-table. We have 0.90 is located here, and we'll have to subtract that from 1 to find the area to the right. We have 1 minus 0.8159, and this gives us 0.1841, but we have to double it since it is a two-tailed test. Let's multiply that by 2. I get 0.3682. This is our p-value. Now, if you're using technology to do this, you don't have to double the p-value. The computer does the doubling for you. This is only if you're doing it by hand, we need to double the p-value. In step 5, we ask, is the p-value less than alpha? Is the p-value less than alpha? No, it is not. We do not reject our null hypothesis. There is not enough evidence to conclude, and in this case, let's look at our alternative hypothesis to make a conclusion. There is not enough evidence to conclude the percentage of millionaires that can wiggle their ears is not equal to 18%. We do not reject the null hypothesis. There is not enough evidence to conclude the percentage of millionaires that can wiggle their ears is not equal to 18%. Now let's use our calculator to confirm our answer is correct. We know the sample size is 337, and there were 67 millionaires that could wiggle their ears. Our null hypothesis is 0.18, 18%. And since this is a two-tailed test, make sure to enter not equals and click calculate. Our test statistic is exactly what we have, and our p-value is pretty much the same. This implies we did the problem correct. Now on your homework, you're welcome to use this statistics calculator to check your work. Question 3. Test the claim that the proportion of households that have firearms is smaller than 40% at the 0.10 level of significance level. Based on a sample of 700 people, 38% of households have a firearm. We always start the problem by stating our claim. In this question, we want to know, is the proportion less than? We're claiming it is less than 0.40. Now, what's the complement to this? The complement is the opposite. So we're going to say P is greater than or equal to 0.40. Now we could do step 1. The null hypothesis is always the one with the equal symbol. So we'll say P is greater than 0.40. The alternative hypothesis is the one without the equal symbol. That's going to be our claim. P is less than 0.40. In step 2, just state alpha. Alpha is 0.10. Now in step 3, we'll use the formula Z equals P hat minus P divided by the square root of P times 1 minus P divided by N. Now P hat is equivalent to X divided by N. That's our number of successes divided by our sample size. To find the number of successes, we're looking for 38% of 700. So how do we find 38% of 700? That's going to be 700 times 0.38. And that gives me 266. The number of successes is 266 divided by our sample size of 700 households. And we can simplify this to 0.38. We have P hat is equal to 0.38. P is 0.40. Our sample size is 700. And so we have everything we need to find our Z. Let's plug in the numbers. We have Z equals 0.38 minus 0.40 divided by the square root of 0.40 times 1 minus 0.40 over 700. Let's figure out what our test statistic is. Please try on your own to calculate Z. And my test statistic is equal to negative 1.08. In step 4, let's find our p-value. Now I need to figure out, is it a one-tailed test or a two-tailed test? For that, we'll look at the alternative hypothesis. If you look at our alternative hypothesis, we're going to reject the null hypothesis if it's far below what we expect. Now, in this case, we have a one-tailed test. It's a one-tailed test because the alternative hypothesis has a less than symbol. This must be a one-tailed test, so we do not need to double the p-value. And we're looking for the area to the left. So let's use our Z table to find the area to the left of negative 1.08. the area to the left of negative 1.08 is going to be this number. It's going to be 0.1401. Now we can finish step 5. We ask, is the p-value less than alpha? Since the p-value is not less than alpha, we do not reject the null hypothesis. There is not enough evidence to conclude. And recall, our conclusion is always in terms of HA. Let's look at HA. We want to say that the percentage is less than 40%. We do not reject the null hypothesis. There is not enough evidence to conclude that less than 40% of households have a firearm. Have a firearm. Since the p-value is not less than alpha, we do not reject the null hypothesis. There is not enough evidence to conclude that less than 40% of households have a firearm.